Okay, to solve question 57 on the geometry homework, what we're going to do is we're going to actually find the slope of each diagonal and the length of each diagonal. And we're going to use that information to determine if this parallelogram is a rectangle, rhombus, square, or none of the above. It does say in the direction that it wants us to graph it. I don't want you to graph them. You can if you want, but I do want you to use the slope and distance formulas and the theorems of quadrilaterals that we discussed today and last week to determine which of the special quadrilaterals it is, if any. Now, we use a different method on 55. If you want to go watch that, you can. Either method is perfectly fine. In 55, we found the slope and the length of each side and compared those. That was actually a total of 8 calculations, 2 for each side. In this case, we're going to actually do 4 calculations, 2 for each diagonal. Now, because these vertices were given in consecutive order, PR is one diagonal, so we're going to find the slope of PR. Negative 3 minus 4 is negative 7. 2 minus the negative 1 is 2, plus 1 is 3. So we have a slope of negative 7/3, and the other diagonal would be SQ, or QS. Negative 1 minus 2 would be negative 3. 4 minus the negative 3 would be 4, plus 3 would be 7. Now, if you look at these quickly, you might make a mistake. Now, these are in fact reciprocals, but they're not opposite reciprocals. Opposite means they're different signs. Both of these are negative. They are in fact reciprocals, not opposite reciprocals, so these are not perpendicular. Now, you have to be familiar with your properties, because if diagonals are not perpendicular, you know that if it is special, it has to be a rectangle. But in order for it to be a rectangle, we have to prove not only are these diagonals not perpendicular, but they're congruent. So we need to find the length of PR and the length of QS to make sure that they're the same. It's not just a regular parallelogram. Now, if you look at the slope and the distance formulas, you need to notice these similarities. The rise y2 minus y1 is repeated in this quantity, which is squared, and the run x2 minus x1 is repeated here. So when calculating the distance, if we already have the slope in non-reduced form, we're going to square the y2 minus y1, which is a negative 7 squared, plus x2 minus x1 squared, which is 3 squared. We have 49 plus 9, which gives us the square root of 58. Don't worry about reducing it. We're only looking to see if these are the same. For QS, we have rise, negative 3 squared, plus the run squared, x2 minus x1, 7 squared. Again, we have 9 plus 49, so we have the square root of 58. So we have diagonals that are not perpendicular, but they are congruent. So this is, in fact, a rectangle. Now, 55 is also a rectangle. We use different methods, a different method for proving that. In fact, it actually took a little more work, so maybe you prefer this one. Either way, you do need to understand one, and hopefully make the connection here between slope and distance. Like I said, in 55, we didn't have as much time in class as I would have liked to have gone over this well enough to put it in our notebook. Again, I don't want you to put anything in your notebook that you don't fully understand. So we will take some more time tomorrow at the beginning of class and also during class to go over a couple more of these examples. If you have questions, again, please ask, and we'll get this all straightened out for the test on Friday. So that's 57. Again, if you want to see another method, take a look at 55.